Hey guys, this is Johnny, and in this video series I'm gonna create a hack and slash demo using Godot. The source code of this project is completely free and you can download it from itch. This project is made on top of my Godot 4 third-person controller demo, so if you haven't watched the series, I recommend you to watch that before you start this one. The hack and slash demo will contain these features for now, but the list might get changed as I make progress. As you can see, the features list is very straightforward, and also you're welcome to suggest any features in the comments. I may also add features or fix bugs even after I'm done with the videos, so you can stay updated with those if you follow me on itch. In this video I'm gonna show you how I'm making the active skill system which the player actively delivers. I could name this character skill, but I want to create a more generalized skill system which can be tied to a weapon, character or any other objects. That way we can change weapons and get different types of attacks from them. The active skill will have 3 phases: Windup, Delivery and Recovery. Each active skill will have their own animations and durations for the 3 phases. I've attached this icon to the class, so if I add them in the scene, it's easier to see them. As you can see, I've created this sword and attached it to the character using Bone Attachment 3D. In the active skill script, I've added some essential variables and a little bit of code which I'll explain as I go through this video. Here I'm gonna add this node which would contain all the skills of this weapon. I'll create a script called skills container which will be responsible for activating the skills. In the animation tree, I've temporarily replaced the animations of the upright stance with the sword animations. I'll modify this section when I'm making the weapon switching system. I'll add this transition node and name this attack transition which will show the attack animations. I'll be switching between the animations in the code, so I'm gonna keep 2 buffers in the animation tree and switch between them. So what I'm gonna do is, if the player is not attacking, the end attack transition state will be active. As soon as the player starts attacking, I'll take the animation name and set it in the first buffer. Then the transition state will be switched to the node. If the player is going to do another attack after this one, the next buffer will take the animation name from the next attack and will simply switch to that state. So it's going to alternate between these 2 transition states as the attacks keep going one after the other. This way we can make sure there is a smooth transition among the attack animations. I'll name this state end attack and these 2 as attack buffer 0 and 1. For attack buffers, I'll create 2 blend trees and each one will have its own animation and a timescale node. I'll keep the same name for the nodes in both of the blend trees, so it's easier to create a reference in the code. No need to assign the animations here, as this will be done in the code using the animation names from the active skill objects. In the skills container, I'll keep the references to the animation tree and the relevant animation nodes here. Here I'm keeping a list of active skills available. The animation tree will be assigned from the active skill controller script, which will be responsible for calling the functions from the skills container. This is because the skills container could be tied to a weapon and the active skill controller would be tied to the character, so the skills container might be loaded at runtime. I'll assign the rest of the animation nodes in the code. I'm also going to need some timers to switch between the attack states, which will be stored here. I'll assign the ready state here, as the attack will be allowed only if it's in the ready state. Here in the ready function, I'm assigning the attack transition node and I'm instantiating the timer nodes and connecting them to the individual timeout functions. The attack phases are pretty straightforward. In the start attack function, I'm stopping all the timers, setting the current active skill and switching the attack buffer. This function basically switches between the attack buffers. This line toggles the attack buffer ID between 0 and 1. And here the animation nodes are assigned inside the attack buffer, which is a blend tree. The animation name parameter is found from the active skill class, so for each skill object I'm gonna set the animation names. As there is no combo system yet, I'm gonna temporarily switch between the active skills one by one for testing. And then the windup function is called. Here the state is assigned as winding up, and the attack transition node's crossfade time is set as the windup duration found from the current active skill. With this function, I'll set the transition value of the attack transition node as the current attack buffer, and with this one, I'll set the timescale to 0. This way, the attack animation will be stuck in the first frame, and the character will go from current animation to the windup animation with the duration value of this. The windup timer will also take the same duration, and as soon as the transition to the first frame is finished, this function will get called. In the deliver function, the state is assigned as delivering, and the buffer timescale is set to 1, so the attack animation is played. and the delivery timer is started with the duration value of this variable from the active skill. After the timeout, the recover function is called, and it's pretty much the same as the delivery function with the variables related to the recovery phase. After the timeout, the state is set to ready, and with the end timer, the attack transition is set to end attack, so the character can return to the non-attacking animation. The start attack can only be called if the state is ready, so if the attack has reached here, if I'm not immediately calling the next attack, the last frame of the animation will stay for a moment. The active skill controller is a part of the player controller and will be in charge of calling the functions from the skills container. Here I'm manually assigning the necessary variables, but as the skills container is tied to weapons, it may be assigned from another controller like weapon switcher. In the player script, I've added a new signal called press primary fire and added some new inputs called primary and secondary fire, which are mouse left and right. The signal is emitted here, and here I'm setting the stance as upright when attacking. The pressed primary fire signal is connected with this function from the active skill controller, and here I'm gonna simply call the start attack function. I'm also checking if the skill is active with this function, so I can ignore the function call when the skill is already active. As you can see, the attack animations are playing nicely. I've already put the values of the attack phases, which you can properly see if I slow this down. So now I'm going to modify some functionalities of the movement, animation and the camera controller. I've introduced a new boolean variable in the player script called isAttacking, and here in the camera script, I'm returning here so we don't change the FOV anymore when we are attacking. I'll also move this code into its own function so I can call this later. In the movement controller, these three functions are ignored when attacking, so the jump functionality is completely disabled while attacking. Also, the movement state should not be changed as I'm gonna use unique acceleration values for the active skills. And the movement direction shouldn't be changed as well, as I want the player to face the attack direction while attacking. I've created a timer called dash timer and a vector 3 called dash velocity, and here I've created a dash function that takes a velocity, duration and a delay value. This function starts the timer and sets the dash velocity to the received value. The velocity parameter is meant to be in the local space, so I'm going to rotate this towards the direction variable, which is controlled by the input. This line simply adds a delay to this function, and with this function I'll rotate the mesh root towards the direction using a twin, as I'm going to disable the movement rotation when attacking. This will make more sense when I show you these lines. In the physics process, I'm checking if the dashing is active, which means the timer is active, and set the velocity x and z values to the dash velocity, and if the player is attacking, they become 0. So when the attack starts, if there is a dash delay, the velocity is 0 at first. As soon as the dash starts, we switch to the dash velocity. If the dash and attack has ended, the mesh rotation with movement direction is enabled. But because we're using lerp with a rotation speed, the player does not instantly look where the direction is. So as we ignore these lines when attacking, the attack may not always land where the direction is intended. So that's why I'm using this function to forcefully rotate the mesh root towards the direction using a twin. This way I can make sure the attack is landing in the direction I want. I'm also using lerp angle here with a value of 1 as the interpolation, so the mesh root takes the shortest way to rotate. In the skills container, I've created a signal called completed recovery, which is called after the recovery is finished. And in the active skill controller, I'm connecting it with this function. Here I'm setting the player's isAttacking as true, and I'm going to set the acceleration value of the movement controller from the currently active skill. I'm going to call the dash function and put the parameters from the currently active skill, and here I'm going to call the setFOV function I created in the camera controller, so each attack can have its own unique camera FOV value. I'm also storing the last movement state with this variable using this function, which is connected to the change movement state signal of the player script. This way you can see here, I can get back to the proper movement state after the attack is complete. I've also added a sword trail effect using an add-on called GPU Trail. I'll provide the link in the description for this. You can download, unzip and add this to your project as is. You can simply add the GPU Trail 3D node like this and immediately see the result. I've added this as a child here and positioned it like this. I also created a simple texture and gradient here. In the active skill script, I've added this VFX variable so each active skill can have its own VFX. In the skills container script, I've created these two functions to play and stop the VFX. Here I'll create a simple scene tree timer which takes the value of VFX delay from the currently active skill. And after the timeout, it shows the VFX node. Then another timer takes the value of the VFX duration and then calls the stop VFX function, which hides and restarts the VFX node. The add-on shows a glitch if I show it again without restarting it. You'll notice when the VFX is shown for the first time, there is a frame drop. To fix that, in the active skill script I made this load VFX function which shows the VFX for 2 frames and then hides it. This way it loads as soon as the scene loads, and now you can see there are no frame drops on the first attack.